So, so this is my video on solving exponential and logarithmic equations, right? Okay. So these are very important in real life because sometimes you want to. So, for example, if you want to find out how long it will take, right, for an infectious disease to reach a certain level, right? Okay. Because the infectious disease grows in an exponential model, you will have to solve for the time, which is usually in the exponent, right? So that's an exponential equations, and then we will see in the next section some examples of these applications. But for the time being, let's learn how to solve. So what is an exponential equation? It's equation means it's an equals. There's an equal sign involved, and exponential means there's an exponential involved, right? So let's take this one to start off with. E to the negative x squared is equal to e to the negative 3x minus 4. So now both have base e, so that means you can straight away equal the tops, the power exponent. So we get negative x squared equals negative 3x minus 4. And then if you bring them onto one side, it's a quadratic, so it'll be easier for us to take the x squared onto one side. You get x squared minus 3x minus 4 equals 0. And when you factor that, x minus 4x plus 1 equals 0, you get x equals 4x equals negative 1. Kind of check, actually, it's okay. You can put both numbers into the equation. So that solution is fine. Now let's do another one, the second one, which is 3 times 2 to the x equals 4. Now, in this situation, make sure that you isolate the exponent before you solve. So how do you isolate the exponent? The exponent part is this. So you get rid of 3, you divide out by 3. When you divide both sides by 3, this is 2 to the x, and this becomes 14, because 42 divided by 3 is 14. And now you actually have something like 2x2 equals 4. You need to bring the x down. And the way to bring the x down would be to take the log on both sides, but we are taking log 2 here because the base is 2, and you will see why. So we take log 2 of 2x is equal to log 2 of 14. We have to do it on both sides, okay? But we know that when you have a thing like a log 2 to the x, the 2 and the 2 cancels off. The log and the exponential cancels off. We know that from the result that we got it 5.2, okay? And then we are left with x. So then x is equal to, on the right hand side, we have log 2 of 14. Now we can either use the calculator to find it, or you can use the change of base formula if you don't have the log 2 button in your calculator, which is fine. So log 2 14 is the same as log of 14, the common log, divided by log of the base, which is log of 2. And when you do that, you will get the answer as x equals 3.807. Let's do another one. We want to solve e to the x plus 5 equals 60. So once again, make sure that you isolate the exponential before you do anything. So we bring the 5 over to this side, and we get e to the x equals 60 minus 5, e to the x equals 55. And now because we have the base e, we take the natural log on both sides, right? And then once again, the natural log and the e will cancel off on the left side, leaving us x. On the right side, we have natural log of 55, which you can find using a calculator as 4.007. Let's do another one. So now we are trying to solve this, right? Okay, so 2 times 3 to the 2x minus 5 quantity, right, equals 15. So first of all, you need to isolate the exponent as usual. In order to do that, you need to get rid of the 2. So you get rid of the 2, and then the 2 comes over to this side as 15 over 2, and then you have 3 times 2 to the t minus 5. And now you are ready to take the logs. And which log do you take? Because we have base 3, we take the log base 3. So we take log base 3 on both sides, log base 3 on this, and log base 3 of 15 over 2. And now, as usual, the log and the exponent cancels off, and you get 2t minus 5 is equal to log 3 15 over 2. So 2t minus 5 is, it might be a good idea to find this before you go any further. So log 3 of 15 over 2 is the same as the common log of 15 over 2 divided by the common log of 3. And that actually turns out to be 1.8340. So we have 2t minus 5 equals 1.8340. So we bring the 5 over to this side and then it becomes 2t equals 1.8340 plus 5, which is 6.8340. So 2t equals 6.8340 and you solve for t by dividing by 2 and then you get this. That is your answer. So now let's try to see how we solve a exponential equation which is quadratic in nature. So look at this. So this has an e to the x and an e to the 2x. So e to the 2x is just e to the x squared, because when you use power of a power, the 2 and the x will multiply and will give you 2x. So it's really e to the x squared and e to the x and stuff like that. So it's a quadratic in e to the x. So one way of doing that is just to replace the variable. I'll call e to the x equals t. And if you do that, then this is just t squared. So you get t squared minus 3 times. This is just t plus 2 equals 0. And now we have a quadratic in t, which you can easily factor as t minus 2 and t minus 1 equals 0. You got 2 equals 2, t 2 and t equals 1. So now really take one of them at a time. Okay, so t equals 2, but t is equal to e to the x. So which means e to the x equals 2. So we have one equation here which we need to solve by taking the natural log on both sides, and when you take the natural log, the e and the natural log cancels off. You get x equals natural log of 2, and we can find that using the calculator. This is the answer. And then we look at the other option, which is t equals 1, and we have e to the x equals 1. You take natural log on both sides. Natural log of e to the x equals natural log of 1, and the natural log of any will cancel off. You get x equals natural log of 1, and you get x equals 0. Now let's move on to solving logarithmic equations, right? So an equation like this is actually called a logarithmic equation for obvious reasons, because it has a log in it. So if you want to solve this, first of all, you need to get rid of the log. And the way to go to it is to convert to exponential form. So when you do that, what happens is, because this is e, right? The base goes to the base, so e, and this goes up to 2 to the 3, and that is equal to what is inside x. So right away we get the answer, x equals e to the 2 third, right? That's very easy. What about this? This is even easier. You have log on both sides. There's nothing in front. Make sure that there's nothing in front, right? Okay. And then if there is something in front, take it up as an exponent before you do anything. So because the same base is there on both sides, you can set them equal. So 2x minus 3 equals x plus 4. Yeah, 2x minus 3 equals x plus 4. And that's normal equation. So when you put x onto this side, you get x equals 7. That's the answer to that. Now this requires a little bit of more work. So now you see log of 4x minus log of 12 plus x equals log of 2. So when you have something like this, the first thing to do would be you need to collect the x and condense them into a single log. Okay. So but because we have a difference here, by using the quotient rule, we can write it as log of 4x over 12 plus x equals log of 2. But now we have log, and the same base, so we can set them equal. So we put 4x over 12 plus x equals 2. And then we solve this by what we do is we take the LCD and we multiply both sides by that. So 12 plus x equals 2 times 12 plus x. And then this will cancel off. You get 4x. And 2 times 12 plus x will be 24 plus 2x. So we get that. And now we collect the x's together on one side. 2x equals 24 and then x equals 12. Another one, you want to solve this. Once again, now before you do anything, you need to get rid of the 2. So here it's easier to just divide it off, right? And then so log 5 3x is equal to 4 divided by 2 is 2. So you got rid of the 2, and now there's nothing in front. So we can now want to get rid of the log. The best way to get rid of the log is to convert it in the exponential form. So the base goes to base. The power what is done there becomes the power, and 3x is the one that is left. So we have 3x equals 5 squared is 25, x is equal to 25 over 3. One final example is when we sometimes we get extraneous solutions, like when we solve radical equations, and let's try an example like that. So we want to solve this, right? So solve this. So once again, like we did before, when we have the logs are separated, we need to condense the logs into one place. So we can use the product rule here because we have a sum of logs which is equal to log of the product. So that is equal to log 10 because the log is the same as log 10. 5x times x minus 1 which is equal to 2. And now I can get rid of now I need to convert this. I need to get rid of the log, and the only way to do that is to convert to exponential. So convert to exponential. And when you convert exponential, the base becomes the base. Whatever is down there becomes the power, and you are left with this on the left side. So when we distribute this, we get 5x squared minus 5x is equal to 10 squared is 100. So it's a quadratic. So before we do anything, we take everything onto the left hand side. 5x squared minus 5x minus 100 equals 0. 5 is a common factor. We can divide out and we get x squared minus x minus 20 equals 0. When we factor this, we get x minus 5 plus times x plus 4 equals 0. Two solutions, x equals 5 and x equals negative 4. But be careful because now plug in the values. So now when you put x equals 5, you can notice that the inside 5 times 5 is 25. That is okay, right? So if you put x equals 5, you get log of 5 times 5, which is okay, plus log of 5 minus 1. That is, if you put 5 here, that is also okay because they are all positives. Because the log, whatever that is inside the log cannot be negative, okay? But if you put x equals negative 4, we are in trouble, right? Okay, because why? Because the moment we put that, we get log of 5 times negative 4, right? Which is not good because log of, you cannot put a negative inside the log. Okay, if you remember the graph, log is always on the positive side. You cannot have a negative input for log. Okay, so this is not a valid solution. So the only valid solution is x equals 5. This is an extraneous solution. All right, so that's it for this video, and thank you for watching.